Design for additive is a complicated process that includes file management, testing, changes to STLs, and more testing until the part can be successfully mass-produced.
The first thing we do when we receive a file from a customer is if we don't receive it as an STL, we have to convert it to an STL so it can be put into the estimates and used by our slicing program.
Sometimes we have to change the scale of the file for a more accurate estimate.
We then take a look at the part and evaluate several aspects to make sure that it will print. Some of the things that we change or that we checked for are gaps, mesh, orientation, thickness, etc.
Gaps between parts should be no smaller than 1 millimeter and holes have to be bigger than 2 millimeters to print successfully. If a gap or a hole is smaller, then the remaining resin in the vat has a high chance of sticking and causing undesired distortions and structures not in the STL.
We check the mesh, or the visible part of the STL file, in a slicer or blender for holes, places where the outside of the mesh looks like it will print well, but where the inside won't have any material deposited. This happens occasionally.
There's a mesh repair tool, but we have to do a manual check to verify that we need to run the mesh repair.
We check the orientation to verify that supports are used only where they need to be. Supports leave marks which are undesirable to some customers. So we have to orient the entire model in such a way that we can either remove the marks more easily or so they're not visible to the user. We check the thickness for several things. First, it should be a minimum of 5 millimeters, 0.5 millimeters for the shorter parts, and 2 millimeters for the taller parts. If the part's too thin, then we have to support it. Otherwise, the print will fail because the movement of the part when it sticks to each new layer.
If we find it isn't printable, we make suggestions on how to modify the part or even give permission or get permission. We make those changes ourselves. We also add drain holes to prevent cupping to better improve cleaning.
We also have to try and decide which resin the print would work best, which is another topic for another video. Sometimes we have to design the part from scratch because we don't have a file, or we have a file that's underdeveloped, so we have to draw from an existing file using SolidWorks.
After drawing the base file, if the customer wants it, we add texture. Downward facing surfaces can't be textured.
After we prepared the design for printing, we then support it in various plausible orientations and print them to find out which orientation is actually best.
We then reduce supports to the least supports possible with the smallest tips in order to minimize post-production.
Next, we then remove material to reduce the cost of the part, either by hollowing it out and cutting it or cutting off pieces. We also make sure that it has the smallest possible footprint in the plate for mass production.
When it's time for mass production, we put as many parts as we can fit on the plate and do a quality print. Sometimes this causes the prints to fail because of how they interact with each other. Sometimes they're too close, sometimes they're far away, sometimes they interact with the FPP in a weird way. It always just depends. So we just have to adjust them yet again to make sure that we get the best print with the most parts.
Then we evaluate the part to make sure it looks clean. If not, then we add additional supports to where the print failed, shift the orientations a few times, and print again. We also determine at this time whether the part needs post-processing like sanding, CNC smoothing, or even painting. Each change adds more time to the overall production process.
If the part is part of an assembly, we make adjustments to make sure it fits well. Then, after we have completed our full quality control process, we start the mass production.